Today we're talking about the graphs of log functions. So you're like, what's a log? Well, a log, by definition, is the inverse of an exponential function. So in order to solve any other exponential functions, we do have to know what a log is, because you remember, anytime we solve an equation, anytime we solve an equation, that's an equation, I have to do the inverse operation to solve it. So I would divide here, square root here. So in order to solve an exponential, I need the inverse. So that's what I'm talking about. So if, as you recall, the inverse is when you reflect it through the line y equals x. This is the line y equals x. So this is our exponential growth. Obviously, this is a growth. And then this is the inverse of an exponential growth, where you simply switch the x and the y. So it would be x equals b to the y. It's just poor penmanship. There we go. So the problem is, whenever we solve for an inverse, we do have to get y equals. So how do we get that y out of the exponent? Well, that's an entire unit of work there, and now I can't erase that. So it's an entire unit of work. So we're going to start with simply the graph. What does the graph look like? Well, the graph looks like the flip of, an exponential. That's it. So all different things change. So we write a log like this. We write log base n. Now that n is the same base as an exponent, but we're going to talk about that tomorrow a little. So that base, that's called the base. It's a little tiny, it's a subscript. It's low on the page. Okay? And then this x is called the value. And so when you're looking at this, that one right there means it's a base of n. And it just changes the numbers that when you type them in. Okay? This one, if I do log of x, look, there's no base. There's no little thing right there. Well, when it's not there, it's a 10. And we have something called the natural log. So the natural log is called the ln, and that's the same as saying log base e. And e is a special number we will discuss. It's so special it deserves time on its own. Okay? But e, it's pi. It's a naturally occurring irrational number that we will discuss soon. So in these examples here, the x, or the value in the x spot. So I can write, I don't know, log of x minus 3. This thing, okay, must be greater than 0. It can't be equal to 0 or negative. It has to be positive. Always positive. So that's an important thing. And that comes in, well, when that value is equal to 0, we have created a new asymptote, a vertical asymptote. So that's this guy. It's an x equals. So in this particular case, x minus 3 would be 0. So the asymptote would be x equals 3. If I were to graph that. So all of these where it's just plain old x, the asymptote is at x equals 0. So we're going to play around with that a little bit today. But first we're going to analyze the equations, the exponential and stuff. So we know that these two are inverses of each other. Since they are inverses of each other, the x's and the y's flip. So we know that the asymptote for an exponential function is always y equals, while the asymptote for a logarithm is always x equals. First, pretty straightforward, right? The domain. So the domain is always negative infinity to positive infinity. You can put in any x value at all, and the range, depending on the exponential function, but we're talking about a regular exponential like y equals 2 to the x. Like, we haven't moved it around yet. So it goes from 0 with a parenthesis to infinity. The end behavior, As x goes to infinity, the function, or y, f of x, goes to infinity. If we're talking growth, remember we're doing growth here. And the end behavior as x goes to negative infinity, it approaches the asymptote. Okay. Common point, when you plug in 0 for x, you always get 1. So that's a point in common with all exponential functions, all parent exponential functions, without any shifting going on. No shifts. With an F. Shifts. The quadrant that it's in is 1 and 2. Okay? And this is left intentionally blank because there are no undefined values. But when we get over to logarithms, we do have undefined values. So if we look here, the domain of an exponential, it goes as far as the asymptote, so they switch around. The range kind of comes up here, and the domain kind of goes down there because they get the x's and the y's flip. So it goes from 0 to infinity, or the asymptote to the infinity, and the range is everything. Okay, it goes up and down as far as it'll go. So the same basic idea for this guy, for the end behavior, as x goes to infinity, what just happens? As x goes to, now I can't erase it. Anyway, we'll type it in, we'll write it in black. As x goes to infinity, whatever. The y goes to infinity. Okay, as x goes to negative infinity, well, it can't. So it cannot go to negative infinity. X can only go to the asymptote. In this case, it's 0. And f of x goes to negative infinity. So as you can see, the x's and the y's, or the x's and the f of x, have switched. The common point is 1, 0. When I plug a 1 in for x, I will always get a 0 out for y. The quadrant that it's in is 1. I don't need the parenthesis there. Is 1 and 4. And all the undefined values, well, I wrote them up there at the top. The base must always be greater than 1. And the value, meaning we call it the value, but it's the x value. If I do log of x, this is whatever's sitting here in this spot is the value, must always be greater than 0. So those are the basic pieces, the characteristics of a log and exponential, and since they're inverses of each other, it's how they connect. So now let's just look at a couple and transform them. All right, so logs, all of transformation always have the same basic pieces. Okay, we have our movement of our x, so this is x movement. D is your y movement, up or down. A is your vertical stretch. And there you should, yeah, okay. And if there's anything next to the x ever, that is a horizontal stretch or compression. Okay, so if we're looking at this, I want to graph that. So in order to graph this, first I should look for the equation of the asymptote, because that's related. The domain, the range, the end behavior, all are part of that. So the asymptote is always where this part is equal to 0. So x equals -2 is our patote here. Now we usually draw it with dotted lines. I probably have a better way to do this on this thing, but there we go. It's a nice dotted line. Whatever. Okay. X equals -2 is the asymptote. The domain, so look on the page right before, the domain starts at the asymptote and goes to infinity. So it's going to be going this way. And the range is everything. It goes high and low. End behavior should be as x goes to infinity, y goes to infinity. So it doesn't go up very fast, but it does go up. And as x approaches, now it can't approach negative infinity. The closest it can go is -2. As it gets close to the asymptote, x is going to go, y is going to go to infinity. So we can sketch a graph. The best way to sketch a graph is to plot points. So take a second and plot a couple points. You might be asking yourself, or yelling at me right now, how do I put this in my calculator? This is ridiculous. Okay, I gotcha. Well, putting this in your calculator is pretty straightforward. There are a number of ways to do it, but in essence, the graph should look like this when you're done. What you want to do, you go into the y equals, of course, but then you hit second, window, 5. Okay, hit those buttons, and the log and the base and all that stuff will show up, and you'll be able to put that stuff in. Okay. Undefined values, it's basically just, regular stuff. What I said before. So any undefined values, the undefined values are all x less than or equal to -2. And that covers everything that you need. All right? So try the next one, but it's the same idea. Try and fill out this stuff, and then I'll show you what mine looks like in the end. Okay, so in this case, there's not a whole lot of whole number points that you can use, but you just gotta, estimate as best as you can. Okay, you don't want to be off by too much because they tend to care about that stuff. But the basic idea, the asymptote is at x equals -3. Here's the domain and the range and the undefined values. If you can get those, we're pretty happy. All right, have a great day.